Yeah, so I'm going to give a bit of a brief introduction to Conda and Snakemake. Unfortunately, we are quite tight on time today. So yeah, I'll give an introduction to Conda, which will cover pretty much everything you need to know, but I'm not going to run through anything live on screen, like a live tutorial. There's a Conda tutorial that I've written that'll be up on GitHub. We'll drop the link in the Discord in just a second. And yeah, the slides will be on GitHub as well. And I encourage you to go over that in your own time if you're looking to learn Conda or you think you need a bit of a refresh. So yeah, I think you have the VMs to the 6, we said, so you've got a bit of time to take a look at it. And I will keep an eye on Discord over the next few days if there are any sort of questions, sort of things I can help with. And I'll give you a very brief overview of Snakemake. Yeah, unfortunately, it won't be in much detail because of our time constraints today, but I'll hopefully give you a feel of what Snakemake is, a little bit what it looks like and how to sort of manage software dependencies. And I will link as well to some tutorials on Snakemake that I actually used when I was first trying to learn it myself. Again, I encourage you to look at them in your own time if Snakemake is something you're interested in learning. We'll be doing a lot on Nextflow today. I think you'll find that some of the techniques you learn in Nextflow can be applied to Snakemake as well. They're quite similar in some respects. So yeah, I'll just drop the link to the GitHub in the Discord channel, so everyone's got it. I'll pin the message. Okay, so yeah, let's make a start. Yep, so you should have that link in the Discord, so the presentation's up there, along with the tutorial for Conda in the README. So just to give a overview of Conda. So what Conda is, hopefully most of you have heard of it, but it's a package manager available on several platforms. So it's available on Linux, Mac, and Windows. And it's a way of installing different software packages. A repository called Anaconda. There's over 1,500 packages available to install various data science and bioinformatics software tools. And Conda is very useful because it's a way of creating isolated environments for your software. So something of particular relevance, I think, for bioinformatics software, that quite often there are different, you can get sort of conflicting underlying build dependencies. Let's say you've got software that's dependent on different versions of Python and so forth. So you can isolate your software in these different Conda environments. You've probably heard of pip, which installs Python packages. So Conda offers the sort of advantages over things like pip because you know, the installed software packages can be written in any language, so it supports lots of different software. So just a note on terminology, because I'm a little bit guilty of using these words interchangeably sometimes. So when we talk about Conda, so Conda itself is the package manager, and Mini Conda and Anaconda are the distributions. So the Mini Conda distribution is what is installed on the CLIMB Big Data VM. So that just includes Conda with its minimal dependencies. So essentially that means you're going to have to install software yourself. I'll talk about how to do that today in this presentation. And Bioconda is the channel from which the bioinformatics software is pulled. So why should I be using Conda? So you find it's much easier to install software packages using Conda than trying to install from source. If you've ever tried to, follow install instructions on GitHub for a software package, they're not, always easy to follow. It's much easier to install in a Conda environment. And these isolated Conda environments that can be built can be very useful. So as I mentioned previously, if you've got software of conflicting underlying build dependencies, you can isolate these in the different environments. And you can also use YAML files to create reproducible environments that you can then share with other people. I'll show you what that looks like in a later slide. So getting started with Conda on your VM. So I should bring up the point now. You mentioned previously that there are two of you sharing a VM under the same user. So there's a little bit of complex there, which in terms of you need to initialize Conda when you get started, but only one of you need to run these commands to get Conda initialized. So essentially, to initialize Conda, you have to run this command, Conda init bash, which adds some information to your bash RC, which you then have to reload, which basically just will allow you to use Conda activate and Conda deactivate for your environments. And you'll know if Conda's been activated, because once it's been activated, you should see the base environment, so base in brackets at the start of your command prompts, and Conda activate and Conda deactivate will work properly. This is all explained in the README on the GitHub as well. So when in terms of working with Conda environments, the default Conda environment is called base. That's what you'll see activated at the start of the command prompt when you first set up Conda. So as a general rule, don't install packages in your base environment. Instead, look to create new separate environments to keep your software packages isolated from each other. Essentially, there's slightly different ways of managing that. You might want to put one software package in each environment. There might be cases where maybe you want to have some software together in the same environment for analysis you're doing. But just as a general rule, don't stick everything in one big environment. Look to have some level of splitting them up across several environments. For example, this is an example command on creating a Conda environment for a piece of software called Shovill in its own environment. So the command you'd run is conda create to create your environments. Then these -c flags specify the channels from which the software is being pulled. So when you actually run this on your client VM, you don't actually need to specify these channels, because these channels will be set up in the config. And then you list the software you want to install, that's Shovill. Then you give a name to your environments called Shovill environments. Just a note here again, there's two of you on the same VM. So when creating your Conda environments, you probably want to put your initials on the end of the environment name just to avoid clashing with the other person. So that's one way of building a Conda environment. You can also build Conda environments from environment.yaml files. And these are particularly useful because they can be used to share your Conda environment with others. So on the right here, this is sort of what a YAML file would look like for multi-QC, where you give the name of the environment. Again, if you're doing this, stick your initials on the end to avoid clashing with the other person when you're giving the environment its name. Then the channels are specified, then the dependencies. So you're saying you want to install multi-QC. And you notice here the equals sign for version number. So it's again going back to this issue of reproducibility, that we want to create reproducible environments. So we pin the software version. So every time that environment is built, or someone else goes to build that environment on their machine, it's using the same version of the software rather than just pull in the latest version. And we use the Conda environment command to create an environment from the YAML file. And you can also export an existing Conda environment. So if you're, say, in your Shovill environment that you just built and you want to create an environment file for that, when you're in your environment, you just run Conda environment export, and you can export that into a YAML file that you can then share with other people. So I'm going to talk a bit about Mamba and why you should be using it. So Mamba is pre-installed on your VM, and essentially what it is it's a reimplementation of Conda in C++, where it uses multi-threading for faster dependency solving. So essentially what this means for you is Mamba is just basically a faster way of building Conda environments. So this can be useful. So if you are building a Conda environment with a lot of underlying build dependencies, it'll probably be much quicker to build it using Mamba than it will be to build it using Conda. So it's uses the same command line pass as Conda, so it's quite simple for you to use. If you can recall the Shovill command from earlier, where we were creating a Shovill environment for Conda, it's the exact same command as before. We're just literally just replacing Conda with Mamba. So if you are building Conda environments, Mamba is definitely something to consider using instead, because you'll probably find it's a lot faster. And then once Mamba is built, your environment is the same as before. To get into your environment, it's just then Conda activate your environment name. So there are some limitations of Conda, which we touched on earlier, and there are some advantages too. So the advantages is it is quite easy to use. It's easy, to build Conda environments, either on the command line or using YAML files. It's very widely used. I think most people have probably used Conda at this point. But there can be issues that even with Mamba, environments can be very slow to resolve. If you've had some experience using Conda, you probably have had the experience where you've been trying to build a Conda environment and you've just been sat there for what feels like forever, waiting for this environment to build. And problems as well with this non-deterministic dependency resolution. So what that means is there are differences across platforms. So even though you pinned your software version, the software you're looking to install on different platforms, they're going to have different underlying build dependencies. Certainly if you're comparing, Linux, Windows and Mac. So there can be, most of the time this won't cause you any problems, but there can be issues with this sometimes. That certainly I've seen it, that someone's built their Conda environment in Linux, it's been fine, no issues. Then a Windows user tries to build that environment and suddenly things start to go wrong. So Conda environments, they're not inherently cross-platform. So this is why we're going to be talking a lot about containers today, because it does solve that issue by having that completely isolated environment. So I'm going to give a very broad overview of Snakemake. So Snakemake is a workflow management system, or workflow language that can be used to create reproducible and scalable workflows. So you can create workflows that can scale to the architecture of your compute and create reproducible workflows through Conda and Snakemake with either Conda and Singularity to provide your software dependencies. So yeah, another example of the workflow management system would be Nextflow, which we'll spend a lot of time talking about today. In terms of which one you want to use, it's up to you really. Both you know, very valid choices. Hopefully by the end of the day, you might have a bit of feel of which one's better for you. But they're definitely very useful systems for building workflows, rather than the traditional way of having you know, bash scripts tied together by string. It's a much better way of writing a workflow. And it can sort of use all your existing software and tools, which you can define in Snakemake Rules or Nextflow processes. So Snakemake has a sort of Python-based syntax. If you are a heavy Python user, aspects of it will be quite familiar to you. So if we're looking at the advantages of Snakemake, in particular, certainly for Python users, it will be familiar. It does integrate with Python scripts quite nicely as well. And the way it integrates with Conda can be very useful. And it comes with some nice useful features as well, such as linting, which it just means it sort of checks quality of your code, and it can do things like automatically generate unit tests for you. So in terms of using Snakemake on your VM today or the next few days, you can use Mamba to create a Snakemake environment within Conda. So it's the same Mamba create command again. We give the name of your environment, and say you want to install Snakemake. You can neglect the channel flags, you don't actually need them. And yeah, and then to activate your Snakemake environment, it's just Conda activate Snakemake or your environment name, and then you're away. So just to give you an idea of what Snakemake sort of looks like, it's a Snakemake workflow defines a software analysis in a rule, and these rules are specified in a Snakefile. So the Snakefile, that's just the name of what the file's called. So in general, this is a sort of general template for a Snakemake rule in the green. So you define your rule, you give it a name, you define the input and output files, and then you have your shell command, which will be your command here, or you know, the software you're using, and then you can call your input and output here. So we have an example rule for FastQC here at the bottom. So you can see the input here, where it's using this expand function to feed a list, a sample list through of paired FASTQs. And we define our expected output as well, again, using this expanded sample list. You can see in this case, we've also defined the number of threads we want to use for a rule. And then at the end here, this is our actual command we want to run for FastQC, where we define our output folder data, which you can see then is also in this outputs rule here, and then define our number of threads, which we drop in, and we take our input directive as well. So that's just to give you an idea of what it looks like. You'll find later when we start to talk about Nextflow, Nextflow uses processes, and it's not all that different from a Snakemake rule. This is a sort of template of what sort of things look like with these workflow languages. So in terms of reproducibility, which we'll be talking a lot about today, we need to consider the distribution and reproducibility when creating our workflow. So when building your Snakemake workflow, it's going to be reliant on many different software packages, and it's unreasonable to expect a user to install all these packages themselves. And we want our pipeline to run uniformly, regardless of the infrastructure. So the solution to this is to either package your software dependencies with Conda, or to use Singularity containers. So as we sort of discussed, there are limitations of Conda because of these different underlying build dependencies. So if reproducibility is really important to you, which it should be for research, I would point you to using Singularity containers with Snakemake instead, to have a truly reproducible workflow that every time you run it on the same data sets, doesn't matter what the platform you're using is, it will produce the same results. So just to give you a little idea of how to use Conda and Singularity with Snakemake. So with your Conda environment, if you're using Conda with Snakemake, you can either define your Conda environment for the entire workflow, or you can define it on a per rule basis. I would advise that you look to define Conda on a per rule basis rather than for your entire workflow. Again, because what we've discussed previously, that a large Conda environment can have problems then that's it's got sort of different software, different sort of requirements. So you've got two software packages that need different versions of Python and so on and so forth. You can end up with conflicts. So it's better to define the Conda environment for each rule, which in practice means a different Conda environment for each piece of software. So this is what it looks like in the FastQC rule from before. You just define your Conda directive pointing to a YAML file for FastQC. And what Snakemake then does on the execution of the workflow, the first time you run the workflow, it will build that Conda environment for you. And then subsequent runs of the workflow, it can then use that pre-built Conda environment that I built the first time you ran. And to deploy Conda then and running your Snakemake workflow, you just in your command running workflow, use Conda flag. And you notice in this FastQC rule as well, there's also a container directive here, which tells Singularity to pull a Docker container from a registry called key. We'll be talking a bit more about this later. So you can define these Conda and container directives at the same time. And then it's just the flag you pass when you run the workflow. You use Conda flag if you want to use the Conda directive, and you then use Singularity flag if you want to use the container directive. So you can have this functionality for Conda and Singularity in the same workflow, and then it's up to the user then when they run which one they choose to use. So using Singularity with Snakemake. So again, there's different ways of managing this in terms of you can have one container for the entire workflow, or you define your containers at a rule level. Similarly to Conda, I suggest you define your containers at a rule level just to isolate your software more, and once again, avoid any conflicts, and to keep the size of your container down as well, particularly if you're hosting containers on registries like Docker Hub. You don't want your container to get too big. And in terms of where do you get the containers from, So you can write your own Singularity recipes if you wish to. Like a Singularity recipe or definition file is like a little script, a list of instructions to Singularity on how to build a Singularity image. So we'll see a bit later what Singularity recipe looks like. Or you can choose to use existing container images from resources such as biocontainers. Biocontainers is a project that has many container images pre-built for you to use. They're hosted on both Docker Hub and Key, which I'll talk a bit about later. So you can pull those pre-built images. And there's also a feature as well of Snakemake where you can do this ad hoc combination of Conda environments with containers. So what Snakemake can actually do is it can take your Conda environment as you defined it in the YAML file and build it in the container that you've specified. So this is quite an easy way of getting started with using containers. It's quite a quick way of containerizing your pipeline. So essentially it solves that problem of your Conda environment having different underlying build dependencies across different platforms by having that containerized isolated environment and building it in that container instead, so it'll always be the same. So that's quite a nice way to get started with containerization. Yes, I think that's all I have to say for this presentation. There are tutorials for Snakemake that can be found on their website. Like I said, they're what I used when I started learning Snakemake. I found them really useful. So yeah, I encourage you to have a go at them in your own time if you're interested in learning. And like I said, I'll keep an eye on the Discord if you are having any trouble over the next few days. I'll try and help.